More radicals. Okay. What makes this problem slightly different from the last example is that we have powers inside our radicals in the denominator. So yet a little bit more algebra that we need to do to get this into a form where we can use the power rule easily. So we're going to use the same method that we did before, or rather combining our three steps of change the radical into a fractional power, make sure that you multiply the exponents on the inside of the radicals to the radicals themselves, and then you flip everything up to the numerator. So here's how we do this. We have 3 over x to the 1/3. Standard, we're used to doing this. So we have 4 over x to the 3rd on the inside of the parentheses here to the 1/2 power. We're just getting rid of our radicals. So in the last term, you have x to the 5th to the 1/3 power. Okay. Now the step you want to use is multiply your fractions in your radicals. In your exponents. All right, because that's what the power rules say to do. Not the power rule for derivatives, but the power rules for exponents. All right, so doing this, nothing really changes in the first term. So we're just going to leave that as is. Then we have minus 4 over, now you multiply your exponents, so you have x to the 3/2 plus 1 over x to the 5/3. Just multiplying the exponents. If you need a calculator to do that, be my guest, use one. Okay. So now we have fractional exponents in the denominator. What are we going to do now? We're going to flip everything up to the numerator and change the sign. Standard strategy. So we have 3 times x to the minus 1/3 minus 4x to the minus 3/2 plus 1, or just nothing, rather, x to the minus 5/3. If you like, you can put that 1 there. I choose not to include it. So let's get rid of that. All right. Now we have the stuff in a form where we can take derivatives. Let's do that. Scooch down the page a little bit. Derive this. You're going to take your power, bring it down in front, multiply. So this gives you 3 times minus 1/3 x to the, subtract 1 from the exponent. So what does that give you? It gives you minus 4/3. Do the same thing over here. So you have minus 4 times minus 3/2 x to the minus 5/2, because you're subtracting 2 over 2 if you think about it. Okay? And then in the third term, you're going to bring down your exponent. This whole thing, bring it down. So you have minus 5/3, and then you have an x, and then you're subtracting 3/3 from the exponent. So this gives you minus 8/3 in the exponent. Now, at this point, you can say, hey, we're done, kind of, sort of, with a wobbly check mark because we're not certain, because you found a derivative. Now the rest is just algebraic simplification. So now notice that we're multiplying fractions. So we have 3 over 1 times minus 1 over 3. The 3's cancel out, leaving you with just minus 1 times x to the minus 4/3, because nothing changes about that. Similarly for the second term, so we have minus 4 over 1 times negative 3 over 2. So what does that give us? That gives us minus 12, or rather positive 12, because of the negative times negative, over 2. That'll simplify to be 6. If you want, you can do that now. Then we have x to the minus 5/2, because nothing changes with that. All we're doing is combining the stuff in front of the x's. Okay. Now we can simplify this just a little bit further. This minus 1 doesn't really need to be here. We can just say minus x to the minus 4/3 power. And then 12 over 2, hey, that's just 6. Then we have x to the minus 5/2 minus 5/3 x to the minus 8/3. All right, continuing along, we're going to take our negative exponents, bring them down to the denominator where they belong as a final step. You could also stop here. That's perfectly fine. because that does what the problem asks you to do. So bringing things down to the denominator, you have minus 1 over x to the 4/3 plus 6 over x to the positive 5/2 minus 5 over 3 times x to the 8/3. Okay, so this is also your final answer.